3.5, solving systems of linear inequalities. Read and highlight. Let's go to work. This is the last section of Unit 3, and we will be solving systems of linear inequalities. Reminder that means we are talking about greater than, less than, greater than or equal to, less than or equal to. I'm sure this is going to be in here, but we've already talked about these a little bit. Remember, if it's just greater than or less than, we're going to have a dotted line. If it's or equal to, we will have a solid line. Let's get into the reading here. When solving a system of linear inequalities, the best representation of the solution is graphical. Let's look at an example of a problem and review what we already know about linear inequalities in order to decide how to deal with systems of inequalities. First, recall that linear inequalities in two variables, the best thing to do is graph the coordinate plane. Also, remember that strictly less than or greater than is a dotted line, and or equal to uses a solid line when graphing associated linear equation. So let's start by graphing both of these inequalities. Notice that there is a section of the graph that is dotted, that is double shaded. That would be this section right here. Okay. Since both of the inequalities must be true at the same time, this is the solution area. We can check this solution by substituting the coordinates of a point found from that solution area into both inequalities and making sure both statements are true. For example, the origin, 0, 0, is in the solution area. And if we plug that into both, it is true. It is not difficult to use both of these statements as true, thus justifying our solution area. To check another way is to pick a point that is in a solution area to a single inequality but not the other. Like, for example, negative 4, 0 or 0, 6. Negative 4, 0 cannot be a solution because it's not true in the first equation. 0, negative 6 cannot be a solution because it is not true in the second equation. To wrap up, the graph represents our solution to the system of linear inequalities with a double shaded area containing the points that make both inequalities true simultaneously. I want to go back and look at this by hand as well just for a second. Okay, and I just want to give you a reminder of what's going on here. Look at this first equation. My y-intercept is 1, and my slope is 2, so they go up 2, 1, 2 over 1, up 2 over 1, up 2 over 1. And as we said, because that is a just less than, it's going to be a dotted line. And then just as a refresher, remember I put my pencil on the intercept, and then I read the sign, and that sign says less than, so it would have to shade below. And you'll notice that down there. The second one here, I'm going to do in purple. Okay, again, my y-intercept is negative 4. You can see that right there. And my slope is a negative 1/2. So down 1 over 2, down 1 over 2. You can see that he's done that correctly. And then finally, because there's that line underneath, it's or equal to, that's a solid line. Draw right there. And again, I put my pencil on the intercept, and I read the sign, and the sign says greater than. So here we would shade above. And again, looking for that double shaded area gives us the solution. And that's it. There's only one way to do inequalities, and that's by graphing. Hope you enjoyed Unit 3. Have a great day.